In this video, we're going to configure and demonstrate multi-part upload and transfer acceleration and explain when these features improve throughput and reliability for large file transfers. So when you upload a file to S3 using a standard put request, everything goes over a single connection as one stream. And for small files, that's fine, but for large objects, it creates two problems. A single TCP connection can't saturate your available bandwidth, so you're leaving throughput on the table. And if the transfer fails halfway through, you start over from zero. S3 has two features that address this. Multi-part upload breaks a large object into independent parts that upload in parallel, improving throughput and making failures cheap to recover from, since only the fail part needs to be retried. Transfer acceleration routes your upload through the nearest CloudFront edge location, then across AWS's private backbone network to your bucket, which is significantly faster than the public internet for long-distance transfers. First, we need a bucket. One naming rule to know is that the bucket name cannot contain periods because transfer acceleration uses a DNS-based endpoint that breaks if there are dots in the name. So let's create a bucket and enable transfer acceleration. So in the console, in the search bar, we will type S3 and we will open the service. We will click on Create Bucket. As we said, under the bucket name, we're just going to use letters, numbers, and hyphens, no dots. So we'll do S3-transfer-demo-cc. Okay, we will leave all of the settings as normal. We want to confirm that our region is East 2, and we will click on Create Bucket. Now that our bucket has been created, we will view details. We will click on the Properties tab, and we will scroll down to Transfer Acceleration, and we'll click Edit. We will click Enable for Transfer Acceleration. We can note the accelerated endpoint here, and then we'll click Save Changes. So transfer acceleration is now on. The bucket has a second accelerated endpoint we can upload to. Now, AWS provides a speed comparison tool that demonstrates both features together. It uploads a test file from your browser, from wherever you are physically right now, to multiple S3 regions using both the standard endpoint and the accelerated endpoint, and shows you the actual speed difference. And this is the clearest visual proof of both features working. So let's go to that site now. The URL is https://speedtest.s3-accelerate.amazon-aws.com/en/speed-comparison.html. So this tool starts automatically. And while it runs, we can talk through what's actually happening under the hood. So for each region that you see on screen, the tool is running two uploads, one standard S3 endpoint and the other an accelerated endpoint. And both uploads use multi-part upload internally, splitting the test file into parallel parts to maximize throughput. That's why you'll often see high speeds even on the standard endpoint. Multi-part is doing its job. The difference you're watching is the routing layer, public internet versus AWS backbone. So we can watch the results come in. The regions geographically closest to us will show the smallest difference. The regions furthest away on the other side of the world will show the biggest speed improvement with acceleration. The gap between the two bars is the value transfer acceleration delivers. So if transfer acceleration isn't faster for a particular transfer, AWS doesn't charge you for it. You only pay for the acceleration premium when the accelerated path actually wins. Now, the speed comparison tool showed the visual proof. Now let's show the actual mechanics. What does it look like to use the accelerated endpoint from the AWS CLI? So we're going to click on the Cloud Shell icon in the top of our console, and we're going to run a command to generate a 100 megabyte test file. Here's our command, dd if equals dev/urandom, of equals testfile.bin. So we're going to create a testfile.bin on our local machine. bs equals 1m, count equals 100. So basically here we're reading random data and then writing 100 1 megabyte blocks into a file. Click on enter, tap enter. Okay, before we upload, we want to configure the CLI to use multi-part upload with an 8 megabyte threshold and an 8 megabyte part size. So that is AWS configure set default.s3.multipart threshold 8 megabyte. That's set, and then we will split that into 8 megabyte chunks. So our 100 megabyte file gets split into a number of parts. So here we will set our multi-part chunk size to 8 megabytes. Now the upload, the only difference between a standard S3 upload and this one is the endpoint URL. Everything else works the same. So we want to do an AWS configure, and we want to set the addressing style to virtual. So that's just not a configuration setting. AWS configure, set default s3.addressing style to virtual. And then we're going to run a copy command. So we're going to copy our test file. So we'll do AWS cp test file.bin, and then we will use our S3 bucket name, which is the S3 transfer demo here. So we'll do S3 : S3 transfer demo cc / accelerated -upload .bin. So it's going to upload our test file to this new accelerated upload.bin. And then we're going to specify the endpoint URL. This is the important piece here. This endpoint URL is going to use the accelerated endpoint. So we'll do https : and we'll say s3-accelerate.amazon-aws.com. So this will complete through the accelerated path, and the CLI will split it into parallel parts under the hood. Any application, SDK, or CLI command that supports a custom S3 endpoint can route through transfer acceleration just by pointing at that URL. So let's hit enter. Okay, so our upload has been completed. Let's confirm that it landed in the bucket. So we'll just minimize our Cloud Shell here. We'll hit refresh on our objects, and there you can see our accelerated upload and the 100 megabyte file. And that's it. Our file has been uploaded via the accelerated endpoint, split into parallel parts by the CLI, and then reassembled on the server side by S3 back into a single object. And it's completely transparent to anything that reads it.